Cummins is a global power leader that designs, manufactures, sells and services diesel engines and related technology around the world, with its corporate headquarters in Columbus, Indiana, and an extensive global manufacturing and distribution network. One such manufacturing site is Cummins Engines in Daventry in the UK. With over 250,000 square feet of facility, Daventry is the lead plant for worldwide sales of Cummins high-horsepower engines, supplying international markets in the mining, marine, electricity generating and locomotive sectors. With state-of-the-art technology, the highly advanced Daventry facility produces 12 major engine variants with literally thousands of customizable options. Keeping track of work in progress is vitally important when it comes to guaranteeing compliance with quality and regulatory requirements. As a US-registered business, Cummins is required to comply with Sarbanes-Oxley legislation, forcing the implementation of stringent financial control. And yet, until recently, much of this control was exercised manually, with the associated inefficiencies and the risk of human error ever present. With high volumes of work on its books, Cummins was forced to outsource the engine block debark process to release capacity on the Daventry line. Debarking, or roughing, is the process carried out on the newly cast engine blocks where the rough outer skin is machined off. Initially, the debark operation was undertaken by a single machinist, Newburgh in Derbyshire. In order to meet Sarbanes-Oxley requirements, a process control was implemented whereby the engine blocks were received directly into the Daventry facility from the casting foundry in Germany. This delivery was manually checked against advice documentation before receipt was entered into the ERP system. The blocks were then immediately shipped to Newburgh with a corresponding sub-inventory transfer taking place. By interrogating the ERP system, it was possible to see the total number of blocks which were at Newburgh at any time. After debarking, the blocks were returned to Daventry with a further sub-inventory transfer taking place. The process was functional, if inelegant and prone to error, and for reporting purposes, the ability to only identify quantities of blocks at Newburgh was inadequate. Due to capacity restraints at Newburgh, Cummins sought a second debark supplier, this one being based in Belgium. It made no financial or logistical sense to bring the engine blocks from Germany to the UK and then to ship them back to Belgium. However, by shipping them directly from Germany to Belgium, Cummins would lose its stated control and therefore not meet the Sarbanes-Oxley requirements. This single issue forced a major rethink of the tracking process and caused Cummins to consider ways of tracking individual engine blocks rather than quantities through the supply chain. With the ability to track each block with a unique serial number, Cummins would be able to meet the necessary control requirements, and by applying the use of barcode technology, hardware that was already in place at Daventry could then be used. However, barcoding introduced a significant stumbling block. For quality reasons, the barcode could not be a simple sticky label. A more permanent solution was required. Laser etching and pin stamping were researched, but were found to be incompatible with existing systems, cumbersome and cost prohibitive. Turning to M-Netics for a solution, Cummins selected an inkjet barcode printer manufactured by Image. In trials, Cummins established that it was possible to print directly onto the painted surface of the engine block by taking the printer to the block rather than the other way round. The next obstacle to overcome was the permanence of the printed barcode. The original ink degraded through the various machining operations and transportation pipeline, causing the barcodes to become unreadable. Extensive lab trials resulted in an ink that could survive those processes. The new process requires that the German casting foundry Guinanth advises Daventry of all blocks transferred to the debark suppliers via an email containing unique block serial numbers. When printed, this email is converted using special software into individual barcodes. The debark supplier also notifies Daventry of the individual block serial numbers they receive, and if these two communications are identical, this provides the matching criteria required to meet the control requirements for Sarbanes-Oxley. After debarking, the blocks are shipped to Daventry where they're again scanned, resulting in an ERP system stock transfer from the debark location to the Daventry location. When the blocks are ready to be fully machined, they're launched into production by matching the unique block number to a works order, again using the handheld barcode scanner. After machining and final inspection, the blocks are once again scanned, completing the works order and moving the block into a finished block location. The use of individual unique serial numbers has enabled Cummins to ensure accurate stock reconciliations and reporting during value-added processes. In short, at any time, Cummins knows what they've got, where it is, and what value it represents, thereby fully meeting Sarbanes-Oxley and its own stringent requirements. Looking to the future, Cummins is exploring the opportunities for extending this technology throughout the assembly process, providing further cost savings, productivity gains, and reduction in human error.